Okay, so homework assignment was this guy here, ChangeString, that took a string as a parameter, as well as the position we want to replace and the character we want to replace in there. And it was supposed to build a new string and return that new string, right? How did that go? Not well. Okay, so like a minimum of 10 hours. See, now you can see in his eyes, like, I mean, a while is more like an hour and 45 minutes. And 5 hours? Okay, I'm okay with that. 5 hours? Anybody spend more than 5 hours on it? I really like big numbers. Some of my grad students, I'll give them like because we only meet once a week for 4 hours. So I give them, I mean, this was an easy assignment. I give them harder assignments relative to their skill level. This was medium relative to your skill level, not hard relative to your skill level. But they'll give me this like I spent 27 hours on this. Sometimes you got to be careful because you got to look at the math, and there was 27 hours between. Sometimes there's not.
About 7,200,000,000 microseconds.
Microseconds.
Yeah.
So what is that, like 15 minutes?
2
2
hours.
hours. All right. Well, we got 50 minutes, so let's see if I can solve it in less than 50 minutes. Well, I don't know. That's not always the case in all classes. You never had a teacher give you an assignment that you're pretty sure they can't solve?
In high school, but that's
I had that earlier this semester.
I think that happens. What assignment was it?
The one where you were using the skull and you started getting confused and you were like, wait a minute.
Oh, but that had nothing to do with me not solving it. It was me enamored with my emojis and losing track of my variables.
Well, there was a moment there where I was like, is he forgetting how to do this?
The counter.
Wait, were you programming in Swift and using emojis as variables?
No. I discovered in my keynote, like in here, that I can create emojis. Let's see this if I get it. Ha! See that? It's my magic bar here. It gives me pictures. I think there was a lizard one. Now look at that guy. That's one of my favorites. That looks just like the ones my wife doesn't like in Florida.
Picture of lizards or reptiles in general?
I don't know if it's an innate fear because I think she's relative. I mean, she wouldn't want to like one on her or anything, but I think she's relatively okay with them out in their habitat, but she didn't want them in the house. We had a little, well, I mean, like free roaming in the house. we had one of these little geckos get into the house by accident. He must have been on the outside of the door of the house. When I opened the door, he got scared and ran in. So that was she didn't like that. It was not a fan of that at all. When people told her, oh, it'll be dead in 15 minutes, but it was finding water sources in her shower at the house and leaving little droppings in her shower. So evidence of life. So after about 10 days, we finally saw it crawl into this vent, the house. So I had to get some tools out and dismantle like this wall and produce a body. And I had caught it. It was still alive in my hand. I was just going to throw it outside. No harm, no foul, right? I mean, my wife's like a really nice little lady. She wanted it dead. She's like, you stab it in the head with a screwdriver. We're talking Walking Dead style. And then you throw it out on the porch so its friends know what happens when you come in this house.
Didn't want you to burn it afterwards?
I was thinking, like, as a joke, I was like going to bite its head off or something. I think she might have liked that. So, I mean, they don't want anything to do with people. But yeah, she was not a fan of having it inside her, where the humans live. She doesn't want it there. When we go into their outside areas, then she's okay with them there. She doesn't like them, but she accepts the fact that God has allowed them to walk the earth out there. But inside the house is stabbing the head with a screwdriver. All right, so let's solve this ChangeString guy. So again, strings are read only. So we can't actually change an individual element of a string. Instead, we have to rebuild the string. So we want to build our string from our original up to, but not including position pause. Then we want to tack on the new character, the character that's supposed to be replacing whatever used to be at position pause. Then build the string after position pause. So in order to do this, we're going to need a string to build on. So we'll create a string, we've called it answer here, started off as the empty string, so we can add some new stuff to it. Now we want to have a loop that goes through all the characters in str, okay, all the characters in str until we get to pause -1, position pause -1. How many characters are in str? Specifically, how many characters are in str? I want an exact answer. Remember, functions are generic reusable chunks of code that we write once and we can use multiple times. So people might call this guy passing any string into this, right? So how many characters are in str? The length of str. Yep, so length of str. So that's going to tell us how far we're going to go. So we're going to start a for loop. Now we can probably assume in here that they pass us reasonable inputs. We can certainly do error checking and stuff like that to make sure that pause is not like a negative number or greater than length of the string, that kind of stuff. Go ahead.
Is there any way to do error checking such that, like, if someone passes in something that, like, a type that doesn't make sense to one of the arguments, like, makes the program doesn't crash?
You certainly can. You could ask questions if something is of a type. I haven't shown you that yet. But keep in mind that would actually be something. So, and this becomes kind of that gray area between, you know, loosely typed languages where you don't have to have types, where they were always viewed as, oh, these are the easier languages to learn. And they have this flexibility where we can, we saw last time, we can kind of dual purpose one method. We could pass numbers, we could pass strings, and the operator operated differently on them because the plus sign can do concatenation as well as addition. Well, in a strongly typed language, that wouldn't fly. We would have to define one version of that method to take in 2 integers, and another version to take in 2 strings. Well, in a strongly typed language, that scenario you just said wouldn't exist. If we define a method that takes in a string, an int, and a char, when you call it, you have to pass it a string, an int, and a char. Where what we've done here is we've named our variables here in such a way that we're indicating that we expect you to give us a string. The position probably an int. This guy's probably a char. But in no way is that absolutely required. It's not being enforced by Python. Python, since it's a loosely typed language, says, give me 3 things. Does that make sense? So you can, I'm not going to show it to you right now because we don't want to spend a lot of time error checking, but you can ask, is this dude of this type? That could be a Boolean expression. All right, but we're going to assume that they gave us a string and that pause is a legitimate character in that string, that somewhere in there, and that new char is the character we're going to place it with because we want to work on the algorithm side of this. All right, so we need a loop that's going to go through. So our first loop, put a little comment here, loop through the chars from 0 to pause -1. So go through the string and go to visit each element of the string up to but not including position pause. Because position pause is the guy we want to replace. All right, so that's going to be for I in range. Actually, there's no parentheses are fine there, but they're not required. 0 to pause. And this is non-inclusive, right? So this will go to pause -1. And each time through, we want to just tack. Those are all characters we want to keep. Those are not the dudes that we're replacing. So we're just going to tack them on to answer. So we'll say answer is equal to answer concatenated with my string at bucket pause. Or bucket I, rather, sorry. So I will be 0, then it'll be 1, then it'll be 2, then it'll finally be pos minus 1. And for each of those, we'll grab the character at that position in my string, and we'll concatenate it onto the current version of answer. So if I had the string HELLO, this will be the empty string concatenated with an H. So now this guy is the string H. Then it'll be the string H concatenated with an E. So now this guy will be the string HE, so on and so forth. It gets built up. All right, so that for loop gets me everything before bucket pos. Then bucket pos is the dude I'm replacing, right? So we're going to ignore whatever used to be at bucket pos and instead replace it with new char. So we'll say answer is equal to answer concatenated with new char. Then finally, we want to go through all the elements starting after pos. So pos plus 1 all the way to the end of the string. So for I in range pos plus 1 to length of string, answer is equal to answer plus str at bucket I. All right. So once we're done with those lines there, answer should hold our changed string, the new version of our string with bucket pos replaced by new char. So we'll finally return the answer. All right, so let's go test this. So we'll come down here. We called this guy ChangeString. So let's go ahead and give ourselves a string. We'll say s is equal to hello. Then we'll print s. Then we'll say s2 is equal to ChangeString of s. And let's say bucket 2. And we'll replace that with a p. So it'll be heplo. Okay, then we'll go ahead and print out S2, save that guy. So now just to show you here, I'll print out S again after S2. So you'll see that S has not changed. We built a new string in a local variable in here called answer that was a copy of the original one with one of the characters replaced. We did not modify the original string. In fact, we can't modify the original string because the original string or strings are read-only. Okay, we can't change the stuff that's in there. All right, so let's go ahead and run this. So we would expect to see hello printed. Then we call our function, which returns the value of answer. We're storing the value of that inside of a new variable here called S2. Then we're printing out S2, so we should get HEPLO in this case because we're replacing bucket 2. This is 0, 1, 2. So we're replacing that guy right there with a P. We'll print out our heplo, and then we'll print out the original value of S, which is hello, proving that it didn't alter. Okay? Let's go out to our terminal. Go ahead and run that, and there's our heplo. That make sense?
No, I didn't.
Okay, so if you can give me legitimate questions, I can help you try to make sense out of it. If it's just you're staring at the whole thing, then I would encourage you to kind of walk through it by hand and see how it works. Is there a specific part of this that's not making sense?
Okay, so what's the overall? What are you trying to do there? What were you doing?
This guy right here.
You're trying to make the change string become printable, right?
Well, I mean, I'm taking in a string like hello. I'm taking in the position in that string I want to change, and I'm taking in the character I want to change it to, and this guy should produce a new string. So the version I called it, I passed it a P, so it should produce that guy. So given these inputs, it should spit out something like this. That is the original string with bucket 2 in it. That's this guy right here, because the string has a length of 5. This is bucket 0, 1, 2, 3, 4. So I'm replacing bucket 2 in this guy with a P. So that's what I'm ultimately doing right here.
Aren't those all edited out? No?
These are comments, yeah. These are just telling you what it's supposed to do. So I guess I'd encourage you to go back and watch some of the earlier videos if you have some misunderstandings about strings. I mean, this guy has a length of 5, but the string I passed this guy was whatever was in S down here. So this is an untapped resource. This is what we talked about last class. This is a function. So a function we write once, and if we never call it, it's an untapped resource. Remember last class I mentioned that all of you know how to add a couple of numbers together? But unless I ask you to add some numbers together, it's an untapped, unused utility inside your head, right? Well, right here, I've written the ability for me to hand you a string, hand you a number, and hand you a new character, and for you to spit back to me a string that is the original with that position, the number I gave you, replaced with the new character I gave you. That's the ability, as opposed to the ability of me giving you 2 numbers and you adding them together and spitting it back. All right? So to see that this is reusable, I can go ahead and I can call this guy again. And we'll do S3 on this one. So this is S3. And rather than passing it my variable called S, let's just go ahead and we'll pass this guy elephant. So we're passing him a string. And let's go ahead and change bucket 6 of that guy to a R. So this is 0, 1, 2, 3, 4, 5, 6. So that N should become an R in my final result. So we'll go ahead and print out S3 down here. So S3 should equal elephant with this N changed to an R, so it'll be elephart. That's a good one. I've had worse situations. We had a random string generator we wrote one time that we were testing, and it happened to randomly produce a 4-letter word on video.
Oh.
and it was the good one, I guess. Yeah. Or the bad one, whatever. Huh? Oh, it was completely funny. Just, it happens, right?
Oh, yeah.
It was just pure chance. We were generating random strings made out of the alphabet, lower and uppercase letters, that were between length 3 and 8.
Mm-hmm.
And we tried it we ran it several times just to make sure it seemed jumbled up because we were sorting them.
Yep.
And it just happened to generate one string of length 4 that started with an F, and the moons aligned.
You can only imagine that, yeah. It's
Pretty low chance.
20,
It's 52. Yeah.
2 with 3 and 8. Could it repeat letters or no?
Oh yeah. So it's 52 times 52 times 52 times 52. It's 1 in that. There's the chance of that happening. So it's 52 to the 4th power. So that's 1 in 7.3 million.
And to be in that order.
In that order,
even more
rare, yeah.
Maybe that times 4 or something.
Yeah, so it's.
Right. One would say it's an accomplishment, but no, not really.
Everybody thought it was funny.
Oh, yeah.
Okay, so that's ChangeString for our homework. I'll go ahead and paste that dude onto Slack. Edit this. I'm interested in whether it actually changes the way it. Yep. So by changing the different language, it treated these as comments. So I thought maybe it wouldn't matter, but it did. Okay, so that's ChangeString. So again, emphasizing this idea that strings are read-only. And I think I mentioned last class that we were going to, before we started the programming stuff, we were dealing with conversion problems, right? All right, so we're interested in maybe converting a binary number into its decimal equivalent. So if we review that real quick, here's the problem we're trying to solve. If I gave you the number 1011, for example, I happen to write it in a string format here because that's kind of what we know how to use in Python at the moment. We're kind of drilling these strings. So if I gave you the binary number 1011, I said convert that to decimal, what would you get? Go ahead and take 2 minutes and convert that guy to decimal. Everybody practice that. All right, what do we got? What's this guy in decimal? 0.1011. Oh, let's try again. It's an 11. So this guy's base 2. So I'm going to put some spacing in here. I'm about to show you how to do it. But we have covered this before, correct? So this is the 8's place. This is the 4's place. This is the 2's place. This is the 1's place. Right? So we start at the far right-hand side, and this is always the 1's place. We multiply it by the power as we move to the left. So this is the 1's place, the 2's place, because we multiply it by 2, times 2 is the 4's place, times 2 is the 8's place. So this is 1 times 1 plus 2 times 1 plus 4 times 0 plus 8 times 1, which is 11. So that's 1 plus 2 plus 0 plus 8, which gives us an 11. All right, so this is the binary number 1011 converted to the integer 11. So what we want to do is we want to create a function that does this. So that is a function called binary to decimal, for example, that takes a, we'll call this guy a binary string as a parameter. And this guy should return, oh, sorry. The decimal equivalent of bin string as an int. I'll kick that down a line. All right, that makes sense what we're trying to accomplish here. All right, so if we go back to this guy here, notice we started at the right-hand side. So we started at the end of the string. So I'll put the little string stuff around this. But for right now, pretend like these aren't spaces because I spaced it out to match it up to these guys beneath it. So actually, let's take the string off because that's going to maybe confuse things. What position in the string is that 1? This last position. What bucket is that? Go ahead.
Length of the string minus 1.
Length of the string minus 1. In this particular one, it's 3, right? Yep, so exactly. So we would start at the length of, what do I call it, bin string, minus 1. That's where we're going to start at that. And we're moving all the way to what? Bucket 0. So we need to move backwards. Okay? So we're going to create a loop that does this. But an issue we have here is up to this point, when we've used the range function. Range function has always given us positive value. So let's kind of experiment with this a little bit. So I'm going to come down here. So at this point, I have all these functions written above, but I'm not calling any of them. So if I ran this program right now, it would do nothing, right? I got 3 or 4 functions, however many I have written up there, and I'm not using any of them, okay? So let's mess around with this range thing and see what kind of animal it produces for us. So I'm just going to create a variable here called answer, and we're going to call range 0 to 10. And then I'm going to go ahead and I'm going to print out answer. Oh, that is not this right screen. Oh, same problem from last time. We have to... It definitely wants at least one line of code inside of any function we write. So I just threw a line of code in there. Otherwise, it is screaming that we didn't indent this dude underneath this this function. We'll finish writing the binary thing here in a minute. All right, so when we called range 0 to 10, it said answer equal to this function, not the result of that function. Now, we've seen before that range 0 to 10 gives us a bunch of numbers, a collection of numbers, right? So we talked about last time that a for loop gives us a collection of numbers. So a for loop actually executes this function. So let's test it inside of a for loop then. So we'll say for I in range 0, 10, we'll print out I. And we've seen this before, right? This is going to give us 0 to 9. Just as a refresher, this will give us 0 to 9. Now, what happens if I say 10 to 0? Or the length of a string to 0? We get nothing. I think it's on the outside. Might have to look this syntax up. Maybe it's on the inside. There we go. So there's another version of range that will take in. So this guy looks like a function, right? He looks like the functions we called before. It looks like when we called our ChangeString and we passed it 3 parameters. Range is a function that came with Python. Okay, it's available to us. That up to this point, we've always passed it 2 parameters, the starting position and the ending position. And the default third parameter is always a 1. So if I go ahead and write our generic one of this. So 0 to 10 by 1 is the default of just saying 0 to 10. We don't have to give it that third parameter if we don't want to. We can just accept that default. But what if we want to have that range generated for us, but to have bigger steps than 1 or 2 or stepping in the other direction? So I can tell this step by 3 if I want to. Okay, now we'll make jumps by 3. 0, 3, 6, 9. So in this case, I might want to start at 10. I might want to go to 0 by -1. Now this should take us from 10 down to 0, but what we've seen before is this has been non-inclusive, which means we won't get a 0 out of this guy. It stopped at a 1. So now if we're walking backwards inside of a string, we actually need to get bucket 0, right? Because if I look at my string here, this is bucket 0, bucket 1, bucket 2, bucket 3. So if I'm going to walk through this guy each time, I kind of need to get the all the way down to bucket 0. And I want to start at bucket, as he pointed out, length -1. Okay? So let's go into our code, and let's start off binary string by just walking our string backwards. Okay? We'll just walk it backwards, printing out each character as we go, just to make sure we're kind of hitting the places in the right order. So we'll have a for loop for I in range, and we want to start at, as he pointed out, the length of bin string -1. Now, make sure the -1 is outside of the parentheses here. So length of bin string is a function that returns the number of characters in bin string. Then we want to subtract 1 from that number. All right? This would not make sense to put -1 inside of there. Because now you're saying, give me the length of bin string -1, whatever that is. Whatever bin string is, -1, the minus operator doesn't apply to strings. All right, so we'll start with the first value that we're interested in. Go all the way up to, but we want to include the last value. So we'll say -1, because we want to get the 0 out of this guy, right? And we're going to step by -1. So if this was a 4, this says 4 minus 3, or -1 gives us 3. So we'll start at bucket 3, go all the way up to, but not including -1, subtract by 1 each time through. And let's go ahead and we'll print out bin string at position I each time. So whatever string I pass this dude, it should give it to me in reverse, right? It should print it out in reverse is what it's doing now. We're not returning a value. If I pass this guy 1011, it's going to print out 1101. So there's my binary to decimal. I'm going to give it the string 1011. And this guy should print out a 1, then a 1, then a 0, then a 1, proving that we're accurately walking our string in reverse. Good starting point. All right, so let's go run that. So there's our 1101, walking our string in reverse. All right, so if we go back here, that's what we did up here. We walked our string in reverse. Now, each time we walked our string, what did we do? We kept track of a number here. So we always start in the ones place. Then we multiplied by, since we're working with binary numbers, base 2 numbers, we multiplied by 2. So that became 2. Then we multiplied by 2. That became 4. Then we multiplied by 2. That became 8. So let's use this exact same loop, but instead of printing out the characters, let's print out the place that we're at. So we should see 1, 2, 4, 8, proving that we are correctly manipulating some variable called place, making sure place is a new value each time. All right. So that means we're going to have to start a variable called place. You can call it whatever you want, but place makes sense. We're keeping track of the place here. We'll start that guy off at 1. And each time through our loop, we'll go ahead and print out the current version of place, but we will also set place equal to place times 2. So 1 becomes 2, 2 becomes 4, 4 becomes 8, so on and so forth. All right, so we're still walking our string backwards, but instead of dealing with the characters at those positions right now, we're just watching the value of place get larger for the correct values. All right, so we're kind of taking one little step at a time, proving that we're getting the correct values here. So we should see 1, 2, 4, 8 for this particular string. Since there's 4 elements, this is place 1, 2's place, 4's place, 8's place. So there's our 1, 2, 4, 8. So we're multiplying the value of place correctly. Now, when we did our sum over here, we took this value, the character of that particular place, but we needed the numeric version of that. And we multiplied it by the current place. So this is 1 times 1 plus 1 times 2 plus 0 times 4 plus 1 times 8. Make sense? So whenever we're summing up a bunch of values, we have to create a little variable for remembering that. Right? If I tell you to sum up a whole bunch of numbers, I kept feeding you numbers. I say, okay, 1, then 3, okay, that's 4. I say another 2, that's 6. Inside your head, you created a little place that you accumulated that value, correct? We're going to have to create memory here for doing the same thing. So we can call it sum, we can call it answer. So let's call it sum. We'll start that guy off at 0. Now, each time through here, we want to multiply the current place. So we want to say sum is equal to sum plus the current place times the current value. Bin string at bucket I. So as we walk our strings backwards, this is going to boil down to the character at position I. This is going to be the current value of place. We'll multiply those two guys together, and we'll store that inside of sum. And then we'll make place twice as large as it used to be. All right. Unsupported operands plus for an int and a string. Okay. What's the problem with that? This guy's a string. We're trying to do concatenation, right? But this guy is ultimately a number. How do I turn numbers into strings? The length tells us how long a string is. We had 2 little converter guys, right? We had int and we had string, str. So we can just wrap this guy inside of an str. And that will say, as long as it makes sense for whatever's in here to become a string, I'll go ahead and make it a string. Now we can apply the plus symbol to a, oh wait, this is an int, and that is now a string. Hold on a second, let's look at that error message. The error message says we can't apply the plus sign to an int and a string. It was implying that our second value there, this guy, was actually a string. That's kind of weird, right? Just like the plus operator here has dual purpose. It works for addition and concatenation. The multiplication operator has dual purpose as well. So what I'm going to do here, just so we can see it before we sum stuff up, I'm just going to print place times binary string. This guy boils down to a character, like a 1 or a 0 in this case, because that's the types of chars that we're passing in, right? We're passing in a string 1, 0, 1, 1. So if we extract each individual char from that, it's going to be the character 0 or the character 1. So I'm taking the character 0, the character 1, and I'm multiplying it by some number. That guy produces a string. This is the number 1 duplicated 1 time. This is the number 1 duplicated 2 times. This is the 0 duplicated 4 times. This is the 1 duplicated 8 times. So multiplication operator, the multiplication symbol, when applied to a char or applied to a string, produces that many of those guys next to each other. So to show you that as an example down here, I'll go ahead and just print out LOL times 30. So we're going to get 30 LOLs, and if we want to have some spacing between it, that way we really get the laughter going, we'll LOL space 30 times. This will glue LOL space to itself 30 times, printing the result. That makes sense? Now, how useful is that? Who knows? You might bump into some sort of issue at some point that has you benefit from something like that. The thing that comes to mind that we'll probably end up writing at some point for another problem we do is, let's say you have two strings and you want to make sure that they're the same length. So sometimes what you'll do is you'll pad one of the strings with, underscores or something like that, or even spaces. Okay, or maybe you have two string representations of numbers and you want to make sure that they're the same length. So if you have one that's length 5 and another one that's length 3, the 3 needs to be padded by 2. So you can do 2 times whatever your padding character is and then concatenate that onto your shorter string. So it's kind of a quick way of getting something of a new length. That might be one example where this little multiplication thing comes in handy. Otherwise, from my perspective, it's kind of more of a trivia tool or something like that. But at least now we know that this operator is doing multiplication here, but it's doing, I don't know what you'd call it, duplication, concatenation, duplication there, something like that. So we'd really like for this not to be doing duplication. We'd really like for this to be doing math. So I need this guy to not be of a type that tells Python, you're the duplicator. I need this guy to be of a type that tells Python, you're the multiplication operator. So we need this guy to be a number. So we can convert that guy to a number by just wrapping it inside of the int constructor. So anything we pass this function, as long as it makes sense, if you pass it the word toast, turning toast into an int maybe doesn't make a whole lot of sense, but if I pass it the char1, a human being looks at the char1, they'd say, oh, that probably should become the number 1, which makes some sense, right? All right, so we can go ahead and do that. Now, again, we're just printing them here, okay? So we should see now the actual multiplications. This was still our 30 times, so let's get rid of this guy, the 30 times of that. So this is going to be 1 times the int version of that guy, and we're printing that. And then place is becoming bigger. So this is 1 the first time, then 1, then 0, then 1. So this should be place times 1 is, so we should have a 0 in the third spot. That's really what we should see right there. So this was 1 times 1. This was 2 times 1. This was 4 times 0. And this was 8 times 1. So now we want to sum those values up. So instead of printing them, we want to say sum is equal to sum plus the current place times the numeric version of bin2string. Okay? And then at the end here, after we've gone through this whole for loop, we want to go ahead and return our sum. So down here, we'll say answer is equal to binary to decimal of that guy, and then we'll print out answer. And this should be an 11 in this case. So there's our 11. So I want to put some more numbers in there. There's 747. That was what I was going for, that exact value.
Thinking about planes.
Thinking about planes. Flying somewhere south where the weather's better. All right. Questions about this guy. So now logic would say that we might want to write a version of this for converting octal to decimal, right? Base 8 to base 10. That works the exact same way, except instead of multiplying by 2, we multiply by 8. So if we had the value 127, and I told you that was an octal, and we wanted that in decimal, this would be 7 times 1 plus 2 times 8, because 8 times 1 is 8, plus 1 times 64, 8 times 8. So this is 64 plus 16, so that's 80 plus 7 is 87. Make sense? So if I want to write this exact same thing, but for octal, we would say octal to decimal, and we'll call this guy ChangeString. But instead of multiplying by 2, we'll multiply by 8. And I'll just change all my variable names to ChangeString instead of binstring, even though that didn't necessarily matter, but that's for our eyes. And then I can go ahead and I can print out octadecimal of 127. And there's my 87. Now, change this thing to say oct. For your homework, we'll do the more difficult one. Hexadecimal. This guy returns the decimal equivalent of hex string as an int. Remember, hex is base 16, but the twist here is with hexadecimal, our legal digits are not just 0 through 9. In binary, it's 0 to 1. In octal, it's 0 to 7. In hexadecimal, it's 0 to 9, and then A through F. An A is a 10, a B is an 11, a C is a 12. Now, I can tell you that the integer version of A is not going to give you a 10. So for your logic, it's going to be a pretty similar logic to this, but you're going to have to figure out how can I give myself a 10 when octstring at bucket I is a A, instead of giving me what it would give you is the Unicode value of A, capital A, which would be I think it's a 67, something like that. All right, so for your homework, you're writing hex to decimal, which should work just like binary to decimal and octal to decimal, except it should work for all hexadecimal inputs, which includes A through F. Go ahead.
Should it require the 0x prefix?
No. Just takes in your normal numbers. They just happen to be hexadecimal. Throw it. It's down. Throw it. All right, and I'll post the couple functions we wrote today up on Slack, and I'll see everybody on Monday.